Hello friends, welcome to in this lecture. In this lecture, we study of design of doubly reinforced beam. First of all, what is meant by doubly reinforced beam? When steel provide on the tension side as well as on compression side, this section called as doubly reinforced beam. So when design a doubly reinforced beam, when the depth of the beam is restricted or the beam is going to the over-reinforced section. So IS code does not permit to design a over-reinforced section. So we require design a doubly reinforced section. So first of all, study analysis of this doubly reinforced section. This is a cross section of the beam having width B and effective depth D. This is the AST and this is the ASC. ASC means area of steel in compression side. This is the DC. DC means the distance between top of the beam to the center of the ASC. Then this is epsilon S means strain in steel. This is the epsilon C, that is strain in concrete, and this is the epsilon SC means strain in steel in compression side, and this is the distance, that is XC minus DC. This is a stress diagram. This is T force is equal to, that is 0.87 Fy AST. The C force due to that only for concrete, that is equal to 0.36 FCK B into XU, and that acted at a distance of 0.42 XU. And then this is the load, or this is the force due to compression steel, that is FSC into ASC. This compression force act at a distance of DC from the top of the beam. So following steps are follows to calculate MR of the beam for doubly reinforced section. In given data, the given will be B, width of the beam, effective depth, area of the steel in tension, area of the steel in compression, then DC, effective cover on the compression side, and material. And you should find out moment resistance of that particular beam. So next step will be calculate position of actual neutral axis, that is XU. That's why you need to equate that C is equal to T. The C force is equal to now load carried by the concrete plus load carried by the steel in compression side. So load carried by the concrete is 0.36 FCK B into XU, and load carried by the steel in compression side is equal to FSC into ASC. This is the total C force. Then T as usual 0.87 Fy AST, where FSC is a new term. FSC means stress in compression steel. So for FSC, Fe250 stress strain curve is linear one, that is strain in concrete is directly proportional to strain of compression steel. From strain diagram, epsilon SC is equal to 0.0035 in bracket XU minus DC upon XU, that is FSC is equal to epsilon SC into 2 into 10 raised to 5 is not greater than 0.87 Fy. So FSC is equal to 0.0035 XU minus DC upon XU into 2 into 10 raised to 5 for Fe250. So FSC is equal to 700 in bracket XU minus DC upon XU. By using FSC value, calculate XU and compare XU and XU max. Once again we know that XU max depends upon grade of the steel. For Fe250 it will be 0.53 D, for Fe415 it will be 0.48 D, and for Fe500 it will be 0.46 D. And calculate MU. MU is equal to, that is 0.36 FCK B into XU in bracket D minus 0.42 XU. This is due to concrete plus FSC into ASC into D minus DC, it is due to compression side steel. The summation of both moment is equal to your final moment of that particular beam. This FSC is limited up to for Fe250. Suppose for HYSD bar, the stress strain curve for steel in the junction is non-uniform. So we can't use directly epsilon SC is equal to 0.0035 XU minus DC upon XU. So by using this table we can find out stress, that is FSC value. This FSC value depends upon grade of the steel and DC by D ratio. DC by D ratio means effective cover in the compression side divided by effective depth. So for that point, DC by D ratio 0.05, 0.1, 0.15 and 0.2, the Fe415 and Fe500 steel, the stress will be tabulated in this table. Let us see one example to calculate MR of W reinforcer section. Find MR of beam of M15 concrete 200 by 400 mm effective is reinforced with 4 bars of 20 mm phi for tension side and 2 bars of 20 mm phi for compression side. The effective cover to reinforcement is 50 mm. Use MS grade steel. So first of all, write down given width of the beam is equal to 200 mm, depth of the beam is equal to 400 mm, AST is equal to 4 bars of 20 mm phi. So total AST is equal to 1256.63 mm square. Then ASC is equal to 2 bars of 20 mm phi. The ASC value will be 628.31 mm square. FCK will be 15 Newton per mm square. Fy will be 250 Newton per mm square. And DC is mentioned 50 mm. So this is a sketch. B is equal to 200 mm, D is equal to 400 mm, AST is equal to 4 bars of 20 mm phi, ASC is equal to 2 bars of 20 mm phi, and this is a DC, top to the center of the compression side reinforcement. Then first step will calculate actual XU. For calculate actual XU, equate C is equal to T. We know that the C for this condition is 0.36 FCK B into XU plus FSC into ASC is equal to T is equal to, that is 0.87 FY AST. Put up all values. 0.36 into 15, B will be 200, XU remain as it is XU, FSC will be 700, XU minus DC upon XU into ASC value will be 628.31 is equal to 0.87 into 250 into 1256.63. So it will be rearrange the equation, that is 1080 XU plus 439.81 into 10 raised to 3 XU minus 50 divided by XU is equal to 273.31 into 10 raised to 3 XU. Multiply by XU on the both side. So our equation will be now 1080 XU square plus 439.81 into 10 raised to 3 XU minus 50 is equal to 273.31 into 10 raised to 3 XU. So rearranging the equation, we got the final equation like this: 1080 XU square plus 166.5 into 10 raised to 3 XU minus 21.99 into 10 raised to 6 is equal to 0. This is a quadratic equation. So by using formula, XU is equal to minus B plus or minus square root of B square minus 4AC upon 2A. This is A term 1080. B will be 166.5 into 10 raised to 3 and C will be minus 21.99 into 10 raised to 6. By solving this equation, we got XU will be 85.09 or to minus 239.26. So minus 239.26, it is a not applicable value. So XU will be 85.09 mm. So XU is equal to 85.09 mm. Then next calculate XU max. We know that XU max depends upon grade of the steel. So XU max is equal to 0.53 for Fe250. Then compare XU and XU max. XU max value will be 212 mm and XU will be 85.09. So our conclusion is XU max is greater than XU. So section is under reinforced. Then calculate MR. For MR is equal to 0.36 FCK B into XU in bracket D minus 0.42 XU plus FSC into ASC in bracket D minus DC. Now once again we calculate FSC value. By using that formula, FSC is equal to 700 XU minus DC upon XU, and that FSC value is not greater than 0.87 FY for mild steel. So 700 in bracket 85.09 minus 50 divided by 85.09, its value will be 288.67 Newton per mm square, and that 0.87 FY of that 250 is 217.5 Newton per mm square. So it is greater than that 217.5. So IS code is not permitted to use that 288.67 value. So FSC value will be 270.5. Once again I repeat, this FSC value is not exceed that 0.87 FY for mild steel. So FSC value is restricted up to 270.5 Newton per mm square. Put up all values in the equation. MR is equal to 0.36 into 15 into 200 into 18.09 in bracket 400 minus 0.42 into 85.09 plus 270.5 into 628.31 in bracket D minus DC, that is 400 minus 50. So solving this equation, we got MR is equal to 81.30 into 10 raised to 6 Newton mm. This is the MR of beam, doubly reinforced beam. In next lecture, we discuss design of doubly reinforced beam. Thank you.